Hi, everybody. We're going to be doing starting section Q. I finally finished S. I'm doing it a bit out of order from the lettering system that they used. Anyway, we're going to start relations and functions. A relation is not a function. A function is a relation. It seems kind of weird. It's kind of like this. A relation is the generic term, kind of like cat, and function is the specific term. Kind of like a house cat or a lion. Obviously, lions and house cats are different things. So a function is a special kind of relation, just like a lion is a special kind of cat. Relation is the general term. So a relation is just a matching of two things. It's a pairing. That's a good way of explaining it. Now we want to express the relation that's below, and 0 goes with 0. So we're supposed to fill it in. It's just a pairing of things. Notice the 7 went with the 3, and the 1 went with the 10, and the 8 went with the 11. And of course, the 0 goes with the 0 that we can see there. This one, we want to name the points. So there's the 0.12, and I can see the 0.07, but the point I don't see is the 3,6. And there it is right there. And that is the 0.3 for the X and 6 for the Y, which is the ordered pair 3, 6. Okay, now this is a mapping, and what they're doing is they're saying that 18 goes to 6. Oops. 18 goes to 6, and 6 goes to 16. 20 also goes to 6, and 18 goes to 18. So we have to make sure that those arrows match with the ones that we see there. So we have, oh, it only gives us two choices. Okay, so we have 18 going to 6, and we also have 20 going to 6. We have 18 also going to 18. Now, what's important here is that this is a relation, but because we can't make a prediction, it is not a function. Now, all of that makes no sense whatsoever. So here's my favorite example. I want you to imagine that the mapping that we're looking at are barcodes. You know, the barcodes that you have on products. And the result is the price. And most of us have had experience with this. You scan a barcode and it gives you a price. Well, as long as you scan a barcode and you get a unique price, everything's fine. But imagine that you're behind an old lady at the I probably shouldn't use this example, but imagine you're behind my girlfriend at the store, or worse yet, my mom, and she scans a barcode and she's got 2 cans of beans, and the first one comes up and the price is $1.99. No problem. And the barcode is, say, 00017 or something at the last 5 digits. But the barcodes are identical. And she scans the first can of beans and it's $1.99. And she scans the next one and it's ridiculous. Let's say it's $2.99. My mom would have an absolute cow, because what's supposed to happen is every time you scan the same barcode, you're supposed to get a unique price. And it isn't the amount of the money that matters. It's the fact that she's getting ripped off somehow. Now, this is how you can determine whether a relation is a function or not. Here's that barcode, that 18. I should have used this. And at one point, it's going to 18, and at another point, it's going to 6. That's why this relation is not a function. Very, very important concept in mathematics, because the whole point of mathematics is to create mathematical models and to make predictions. For example, let's say that you're a meteorologist. That's somebody who predicts the weather. And you go on at 6 a.m. and you say, you know what, the high today is only going to be 68 degrees. You're going to have a nice, cool autumn day. And then he comes on at 7 a.m. and he says, by this afternoon, the high today and that same day is going to be 78. You better not wear a sweater. You can all see that the problem is that he's making the same prediction, but giving you different results. And that's a problem. I should have said the same day. I should have said this is for, say, November 1st. And this is also November 1st. And he's making the same prediction for the same day. So I really want you to understand this, because the idea of a relation versus a function is huge. There's a big difference between the two. So anyway, there we have it. More than you wanted to know. Alrighty then. Express the relation below as a graph. Okay, so we're supposed to, as you can see, each one of these only goes to one output. So that's okay. This is a function. 0, 9. Let's see, 2 goes to 2. 3 goes to 6. And 10 goes to 0. By the way, something that some people get very confused about, I should put it a little bit lower, sorry about that. I'll put it down here where the graph is. One thing that some people get confused about is what happens if they all go to the same number? And that's okay. That's that has an actual example in real life. Imagine going to the True Dollar Tree and they're scanning the prices for whatever reason, and the barcodes, they're scanning the barcodes. Well, what's going to happen? Well, you're going to get a barcode, and you're going to do barcode 1, and it's going to cost $1. And then you're going to do barcode 2, and it's going to cost $1. And you're going to do barcode 3, and it's going to cost $1. This is called a constant function, and it is a function because it's very predictable. In fact, it's probably the most predictable function there is. So just so you don't get confused about it. This one is what we call a one-to-one function. In other words, it works both ways. Each one of these is unique. 0 goes with 9, and if we went backwards, it would also work. So this is called a one-to-one function. Anyway, let's take a look at our points. They gave us the 10, 0, and they gave us, that didn't work. Okay, oops. Okay, they gave us the 10, 0, they gave us the 2, 2, they gave us the 0, 9, and they didn't give us the 3, 6. Same problem we had before. God, I'm doing way too much stuff here. Sorry about that. Okay, express the relation below as a graph. So we're just supposed to graph the points. Let's see if we can put them in here. All right, I see 8, 7, I think. No, I'm seeing 9, 9. I'm seeing the 6, 1, but I'm not seeing the 8, 7. So that's 9, so that's 8, and there's the 8, 7 right there. Let's make sure. 8 and 7, yep. Not very difficult. I basically made it too hard for you. Express the relation below, fill in the blanks. So we've got a -2, -5, which I don't see. Are we supposed to graph it? Maybe we're supposed to graph it. No. -5, -5. I'm confused. I wonder what we're supposed to do with it. Oh, I see 2, -5, and I see -5, -5. What I don't see is -5, -3. Figure out what they were wanting me to do there. They just want me to find the missing point. Okay, we've got, let's see if you can see the whole thing here. Barely. Let's see. We've got -2, -3. Shall I circle the points? That one. And we've got -7, -3, which is right there. So we got that one and we got that one. And we have -8, 2, which is that one right there. So the one we're missing is the 1, 8, which is right there. Make sure you go to the right place. Oh, maybe I'm supposed to get rid of those. Let's see. I hope I got rid of them all. I don't see any more blue. I better make sure. I don't want to mess it up. There we go. So you're just supposed to find the next one, the one that was missing. Okay, we're supposed to write the ordered pairs. Get rid of this real quick. So we have a 5, 3. I see it. I have a blank -1. That's -3, -1. So it's this point right here. It's not letting me write. Let's see. Oh, there it is. This is -3, -1. So I have to put in the -3. Oh, there's another one. Oh, I didn't see it. Okay, so let's see which one is missing here. It looks like we have a 5, 3 and a -4, 4. Okay, where's the other one? Oh, there it is. -5, 5, it looks like. Here's the other one that's missing. -5, 5. You just have to find the missing points. It's a little hard because you can't put them all in the same space there. Looks good. All right, express the relation as a table. So obviously we have 5, -7. And we have a -2, 16. I don't think there's any more, is there? No. I spent way too long on this. Uh, express the relation below as a graph. We're supposed to graph the points. You know what? I'm just going to put them over here. I wish they would have put them side by side. -4, -4, 9, -6, -4, 9, and 2, -3. You're supposed to graph the points, that's all. This would have been a good one because, okay, I did that one. We have 9, -6, got that one. We have 2, -3, we have that one. The one we're missing is the -4, 9, which is right there, maybe? Make sure I'm in the right spot, yeah. This would have been a good one to do before we did the graphing. I should have realized that they had a reason for putting these in order. My bad. That's because I didn't do them all. Oh, we have a domain and a range. Interesting. Okay, something to bear in mind, because you are going to hear a thing called a vertical line test. And you can see that these 2 points both are associated with the -4. So we have the -4, which is going to 5. That's right there. And then we also have the -4, which is going to -3. So this problem right here is that same problem with that same barcode giving us different prices. This is the issue where it makes it not a function. It is a relation, but it's not a function. So it's 3, 5 is my other one. This one is the 3, 5. So let's take a look down here. So we have 3, 5, and then we have -4 going to both of them. So it's this one right here. It's like that's it. What? Is there something else? What else am I supposed to do? Oh, am I supposed to pick both, maybe? Oh, I see. They're both the same, aren't they? No. 3. It's oh, I see. I accidentally turned it off. There's the problem. Okay. Can figure out what I did wrong there. All right. Express the relation as a graph. Now we can see that the relation is not a function because of what number? That guy right there is giving us the problem, isn't it? That -6 is going to have 2 different points associated with it. So we have to be careful of that. Oh man, we have a whole bunch of points. Okay, so -10, -8. I'm going to have to write them all. What a pain. Okay, so we've got -10, -8. I've got -6 going to -5 and also going to 0. We have -4 going to 3. Which I can see right here. And we've got -1 going to 0. I don't see that one. And then I have 5 going to 9, which I do see right there. Oh, get rid of that point too. So it looks like -6, -5. I don't see it. I do have a -6, 1, which, oh, that one was there. It's not 0, it's going to 1. Geez, I can't read today. There we go. So this one is done too. Okay, so it looks like we have 3 points we have to put in there. Oh, no. -6, -5 is graphed. Looks like we have a -10, -8, which is right there. And then we also have a -1, 0. This is a really easy one to make a mistake on. I want you to notice that it is on the x-axis. That is an x value. And I think I got them. I don't see any mistakes there. Okay, we have a -9, 9, which I can see. I can also see my 610. See the 610 right there? And there's my -9, 9. And I'm missing my -9, 10, which needs to be graphed. There it is. Let's see if I have a -3, 2. I don't have one of those on there. There's a -3, 2. And a -9, -8 probably is on there. Let's take a look and see. Nope. -9, -8 is right there, isn't it? Yeah, it looks good. So we had some missing. Always worries me that I missed something. All right, let's see. Look at the table. We have a table. And here's one of our problems, the 1 going to 2 different values. And there's another of our problems, the 15 going to 2 different values. So 15 is going to 5 and to 20. This one is not it. Oops. Let me get rid of it. Come on, get off of there. It's not letting me change it. Okay, so this one, 15 is going to 5 and 20. Yep. And the 7 is going to -15, which I'm not seeing anywhere. Oh, I see. Maybe it's up above. There it is. 7 is going to -15. 1 is going to -15 and to 5. Yep, -15. 1 is also going to 5. Looks like it's this one down here. They only want you to just choose between the two, it looks like. Pretty easy choice. All right, express the relation below as a graph. So we're supposed to just graph the points. Oh, nice. That's good. Okay, so good practice graphing points. I like the connect the dot graphs for my kids better, but this one's fine. So it looks like I can't graph this one yet. I can do the -2, -4, which is right there. And I can do the -1, 4, which is right there. And I can do the 5, 0. Be careful, that's on the x-axis. See, that x value will mess you up. A lot of people are going to graph 0, 5, which is on the y-axis. And we have -3, -9, which also I'm going to have to graph in a minute. I already did that one and that one and that one. And I've got 2 more. I've got -2, -10, which is, I'm going to write it here, 2, -10, and -3, -9. So they're down below here where I can't see them. So I've got -3, -9, which is right there, I believe. It sure is. And I have 2, -10, which is down here. And that's all of them. All right. Okay, I got to make a table. Let's see. The one I'm not going to be able to see is the -3, 4 when I roll it up, and the 2, 2. I think I'll be able to see the others. Let's scroll them up here. So I've got -3, 4, which is there. And I've got the 2, 2, which is there. And it looks like the 2, -3 is missing. Looks like I have 2, -3 is missing there, which is this one right there. And I have my 2, -4. So that one's there. And -3, -4, I have that one. And the other one I'm missing is right there. -3, -3. And I'm also missing the 2, -3. Yeah, you're just filling things in. Pretty easy. All right. I guess they want to make sure that you can read tables. I guess that's the main thing. Now we only have to choose between a couple of them. Let's see. Where's my problem child? My problem child is 17 going to 11 and 3. And that's the only issue with this. So I've got 17 going to two different places. And it looks like it's that top one there. Negative 17 going to 17. Yeah. Negative 20 going to 8. It definitely looks like it's the top one. Let's see, 17 is not going to two different places. So it's this one right here. Okay. And notice that they call it a relation. Now, luckily, they don't call it a function. It is not a function because of the 17. Sorry, this one's taking so long, guys. I shouldn't have messed around so much. Okay, so this one is a super non-function because the negative 3, who knows what the heck we're going to get. We have 3 different values, negative 12, 9, and negative 15. Negative 15, and it looks like there's the problem right there. I don't see it going to negative 12 on that top one. And it looks like it is on the bottom one. 18 is going to negative 12 and also to negative 20. Yep, looks like it's the bottom one. Okay, express the relation as a graph. All right, so let's see, what do we got? By the way, this one is a function, and it is, looks like it might be a one-to-one. All right, so let's see here. We've got, I'm gonna have to write them down. What a pain. Okay, so I have negative 9, 1, and we've got negative 5, negative 6, and we've got 3, negative 10, and we have 5, negative 4, and we have 7, 6. Is there only 5 points? 1, 2, 3, 4, 5, yeah. Okay. So looks like we have 3 of them. We've got the 7, 6. So we have that one. And we have the 5, negative 4. And we have the negative 5, negative 6. So we're missing the negative 9, 1, which is right there. And we're missing the 3, negative 10, which is way down there. It looks like, come on. There it is. Make sure I'm in the right spot. Yeah, it looks good. Okay, looks like hopefully we only have about 3 more to go, and hopefully it'll be a quick one. Or, oh, just fill in the blanks. Okay, so let's see, we got a 14, 17. And we have a 20, negative 3. I don't think the order is a problem for these guys. 5, negative 17. I'll have to, maybe I should erase these guys just to make sure I have them so you can see them better. I'll just get rid of that. There we go. And we have a 27, 20 going to 7. And we have a 5 going to negative 20. And we have a 20 going to negative 2. So the question is this relation a function? I keep trying to teach you why you want to get this done. 20 is going all over the place. Notice the 20 went to negative 3, the 20 went to 7, and the 20 went to negative 2. Very hard to predict this. Functions have to be predictable. We have to be able to say, if I have 20 for x, I know what I'm going to get. And remember the Forrest Gump quote, life is like a box of chocolates. You never know what you're going to get. Well, that box of chocolates is a relation, not a function, because you don't know what you're going to get. Oh man, it only went up 1. Come on, guys. It's because I'm going so slow, probably. Okay, we're supposed to write the set of ordered pairs. All right, looks like I'm going to write them down here. Gotta write them down. Okay, we've got negative 4, 3. we've got 1, 3. Oh, be careful. These are so easy to make a mistake on. And by the way, it's okay. These points do not make this relation non-functional. This is a negative 1, 0, excuse me. It's a 3, 0, and it's also a 4, 0. This is okay. This is a function, by the way. Notice that it passes what's called the vertical line test. There are no 2 points on the same x. So all we have to do is fill it in. We've got, let me get rid of this for a second. Come on. Pause it for just a second while I fill this in. There we go. So it looks like we have, let me get rid of this writing here. Looks like we have negative 4, 3. And then we have a negative 1, 3, sorry, 1, 3. And we have a negative 1, 0. And 3, 0. And I'm going to answer the question one more time. 4, 0. Even though all 3 of these x's are going to 0, it's okay. In fact, all of them going to 0 would be all right. That would still be a function. What would be a problem is if these were reversed. So you want to be able to predict what you're going to get. Come on, it looks good. Let's go. Quit. Oh, oops, I missed one. I see. Wait a minute. I didn't see another point. 4, 0. I've got 5 points, right? Where's my other point? Oh, there it is. 0, 5. Sorry, guys. I didn't see that one. And 0, 5 is also on my graph up there. I'm glad it didn't go. Would have been painful to have to start over again. 0, 5 is a y-intercept, and these are all what we call x-intercepts. And 0, 5, it is still a function, so still predictable. There we go. Now I got them all. Alrighty then. Look at the graph. Okay. Let's see what's going on. Oh, we just have to choose. Okay. So our problem child here, the one that makes this a non-function, is this guy right there. Notice that negative 4 is going to 3 different places. Negative 4 is going to 5. It's going to 2. And it's also going to negative 4. And then our 0 is going to 2 different places. It's going to 2, and it's also going to negative 5. So, sorry, that's a kind of an ugly looking negative 5 there. There we go. So this is definitely not a function. And let's see, we have 0 going to 2 and negative 5. It's not that first one. 0 is going to 2 and negative 5, and negative 4 is going to all 3 of those. Yep, looks like it's the second one there. By the way, the domain are all the x values, and the range are all the y values. It's a set. It's called a set of x values and a set of y values. All right, we have a relation, and it looks like it just might be a function, and it is. This is a function, and I'm probably going to have to go ahead and write them down, so I'm just going to start writing them. It looks like we've got negative 3, 5. Shall we put them in order? Negative 5, negative 4. And then we've got negative 1, negative 1. And then we've got 0, 2. And then I've got 4, 4. And then I have 5, 0. And it looks like we have 6 points, and we have to fill them in. Hopefully I can see them all. All right, so we've got, let me get rid of this real quick. Negative 5, negative 4. We got negative 1, negative 1. I'm doing the top row first so that I can move it down if I need to. 4. And then I have -3, 5. This is really good practice for your graphing. 0, 2, and 5, 0. 0, 2, and 5, 0. And this is a function. As a matter of fact, it is a one-to-one function because it works both ways. Any point in the y's predicts a single x value. That makes it what we call a one-to-one function. There we go. And we're getting there. Express the relation below as a graph, and it is not a function because of the 7. The 7 is a problem right there. So let's see if we can, looks like I better write them. We'll write them over here. -10, 2, sorry guys, 2, 10, 7, 7. I'm being very patient today. I'm not completely running out of time, but it's coming. All right, so we've got -10, 2. We've got a 210, which is way up there. We've got a 7, 7, and a 7, 1, and a 6, 8. 6, 8. And it looks like that's it. I think I have 5 points. Looks okay. One at a time. All right. It's good practice anyway. I don't care. All right. Let's see here. I don't know if I can see them both at the same time. Yeah, almost. The only one I'm going to be missing, maybe. The 3, -9, I'm not going to be able to see. So I'm just going to write it down. 3, -9. And I think that's the only one I'm going to have trouble getting to. Oh, yeah, the 6, -9. Okay. This one is not the problem, by the way. It's okay for your y values to all come from different x's, but your x can't go to 2 different y values. Oh, what happened? Oh, I'm losing my connection. And that's disappointing. Okay, guys, losing my connection. It looks like I'm not going to be able to finish it for you. I know you guys can do it. I'm going to pause my recording for a second. Oh. All right, it looks like it got tired of me talking so much, so I'm just going to finish it. We've got -3, 4, and I'm going to go ahead and write them. -3, 4. I've got 3, -9, and 3, 4. These are my problem children here. We have 4, 10, and we have 6, -9. It looks like we have 5 values altogether. So yeah, there we go. Okay, so we have -3, 4, just right there. We've got 3, 4, which is right there. We've got 3, -9, which is down here. We've got 6, -9, which is right there. And we have 4, 10, which is way up here. That looks good. And we're getting there. Okay, so I'm just going to go ahead and write down my points. I see a 0, 5 up there at the top. It's right there. I see a 4, 2. I see a 0, -4. I see a 0, -5. That's these two guys right there at the bottom. And I see a 4, -5. I think that's all of them. Make sure I've got only 5 points, I think. Oh, it was an easy one. Okay. Looks like we're getting a 0, -5, which is the reason it's not a function. And it's going to both. And then 4 is going to 2. And 4 is also going to -5, which is not the top one. Looks like it might be the bottom one. Let's see, 0, 0, 5, and 0, -5. Yep. And 0, -4. Yep. And 4 is going to 2, and 4 is also going to -5. There it is. It's the bottom one. Okay, guys, maybe 1 or 2 more. Almost done. We just have to put in our points. So let me get rid of this. I'm going to go as fast as I can. I know you're getting tired. I am too. Oh, 8, 2, 19, goes with 4. Negative 16 goes to 5. See if you can tell if it's a function or not. 18, negative 20, 14, 20, and negative 1, 9. And is it a function? As a matter of fact, it is. All my x's are different, so there is no way it cannot be a function. And we have one final one, and then we're done. Okay, we are supposed to graph them all. Oh, lots of points. Okay, so 3, 5. I'll graph them in order so that you can see them just in case. Oh, I don't need that. So 3, 5 is right there. Negative 8, negative 5 is right there. Just check to see if you're in the right lines. Negative 8, negative 1 is right there. Negative 10, negative 6 is down here. And our last one, 8, negative 2 is right there. So hope you guys will do these. They weren't so bad, and they're really good practice for your graphing. So hope you learned something more than you wanted, and I will see you back again. Bye, everybody. Oh, that took a long time.